Hello and welcome to the Chapter 6 review video. Here's selected problems from the review packet that students chose that they wanted to see. So here's the first one. We have from complex numbers, we have I minus 3 quantity squared. Remember, you can't just square this and square that. That does not work. We would have to take I minus 3 times I minus 3. And we know when we multiply something like this, we need an area model. I minus 3 and I minus 3. So this is I squared minus 3I minus 3I plus 9. Yeah? And so we can put these together. We have an I squared, we have negative 6I, and we have a plus 9. Now the important thing here is we know that I squared is actually equal to the number negative 1, since I is the square root of negative 1. So if we replace I squared with the number negative 1, we're here, this is going to be, and then we can combine the 9 and the negative 1 to give me 8. Okay? In the second problem, it's not like this because instead of sitting next to each other, they're being added. So if they're being added, that's like a plus 1 sitting there that we can just distribute. So we have 3 plus 4i plus 7 minus 2i. That's all. We don't need to do the area model because they're not being multiplied, they're being added. Now let's take the reals together, 3 plus 7, and take the imaginaries together, 4 minus 2. Done. The other one that was requested here was this equation at the end. We need to add this to make it equal 0. And then use the quadratic formula. Negative b plus or minus b squared minus 4ac all divided by 2a. Come on, come on. Well, okay. So that's negative 2 plus or minus, this is going to be 4 minus 20 over 2. So negative 2 plus or minus, this is going to be negative 16 over 2. Now I know the square root of negative 16, you can split that into negative 1 and positive 16. And I know the square root of 16 is 4, and this is I. So we have 4i. And now the last step, these are planes, so I can divide. That gives me negative 1 plus or minus 2i. Because I can divide 4 divided by 2. That's complex numbers. Special triangles. This is a 45, 45, 90 in problem number 5. So let's remember what that looks like. If we have a 45, 45, 90, then these are both the same, and this is x times the square root of 2. Now this time they give us a leg. So the other leg has to also be 6, and y has to be 6 times the square root of 2. Really kind of easy once you see the special triangle. This is a 60 degrees, which means this one has to be 30 degrees. So let's look at our 30, 60, 90. If this is 30 and 60 and 90, the small side is a, the hypotenuse is 2a, the big side is a radical 3. So here's my small side, here's my big side, and here's my hypotenuse. So we're going from big leg to small leg. To go from big leg to small leg, we would just have to divide by radical 3. So 22.5 radical 3 divided by radical 3 cancels this and just leaves 22.5 for my small leg. Then to go from small leg to hypotenuse, I just have to double that. That's going to be 45. Done. Exponents. Okay, inside here, with the coefficients, we want to divide or reduce. So 5 over 20 can reduce to be 1 over 4. My x's, I'll subtract those exponents when dividing. So that is 3 minus 1 is 2 up on top. And my y's, 1 cancels with 1 down here and leaves 4 left down here. But all of this is to the 4th, so we've got a power raised to a power. 1 raised to the 4th, 1 times 1 times 1 times 1, that's 1. The 4 raised to the 4th, 4 times 4 times 4 times 4, that's 64 times 4, which is 256. X squared to the fourth is x squared, x squared, x squared, x squared, which is x to the eighth. And y to the fourth, we multiply those, and that is 4 times 4, which is 16. So there's our answer here. For number 26, that was the other request. When multiplying common bases, we just add the exponents. So negative 13 plus 4, that is negative 9. And then negative 9 plus 6, that is negative 3. But we never want to leave it as a negative exponent. That means the reciprocal, so we're going to put it underneath down here. Fractional exponents. These are the requests. So 144 to the 1/2 power. We know the 1/2 power is the same thing as square root of 144, which is 12. So this is going to be 12x to the negative 3 all over. Now this stuff, this is the 4 through the 16 to the third, but anything raised to the 0 power is always 1. So I'm almost done, but I don't want to leave a negative exponent. This has to come downstairs. So it's 12 on top, and it's x to the third in the bottom. Problem 9 has a bunch of these fractional exponents. Let's reshuffle the negatives to start with. So anything that's negative needs to change. This one needs to come up. This one will need to come down. These ones, I guess, can stay. So we'll have a to the 2/3 and a to the 1/3 both in the top. In the bottom, this one's going to come down. So we'll have b to the 1/4, b to the 3/4 in the bottom. And these we can subtract. What's 7/8 minus 1/8? That is 6/8. So we'll go c to the 6/8. So now let's see if we can simplify. 1/3 plus 2/3, that is 1. So that is a to the first, which is a. 1/4 plus 3/4 is 1. That is b. And then c is c to the 6/8. And I think we could probably leave it like that. If it asked us to change it to a radical, we would go 1/8 root of c to the 6th. But I think this is going to be just fine for us. Hope that helps you review for chapter 6.